The topic of this video is intersection and conditional probability. Suppose that a certain college class contains 51 students. Of these, 30 are sophomores, 29 are English majors, and 7 are neither. A student is selected at random from the class. Part A. What is the probability that the student is both a sophomore and an English major? First of all, let's identify what we know. I will use letter S to represent sophomores and letter E to represent students who are majoring in English. We know that probability of sophomores must be 30 out of 51 because there are 30 sophomores out of all 51 students. Probability of getting a student who is majoring in English is 29 out of 51 because there are 29 English majors out of 51 students. Finally, probability of getting neither sophomore nor English major, that's what this bar tells me, is 7 out of 51. Part A is asking to find the probability of randomly selecting a student who is a sophomore and is majoring in English. So we have to look for the intersection of these two events. Please notice that if we know that probability of randomly selecting not a sophomore or English major, we can find the probability of selecting a sophomore or English major by using a complement rule. So if P of S or E not, or not selecting a sophomore or English major, is 7 over 51, by subtracting this probability from 1, we will find its complement or probability of S or E, which is 44 over 51. We need this information to be able to find the probability requested in this particular question. I want to remind you of a general addition rule which says probability of A or B is the sum of probabilities of A and B minus the overlap, the intersection of A and B. If I manipulate this a little bit algebraically, look, if I add to both sides this expression will end up being on the left side of the equation. If at the same time I subtract the probability of the union of two events and move it to the other side, I can have an alternative version of the above formula that looks like this. Probability of intersection of A and B is equal to probability of A plus probability of B minus probability of the union of A and B. This is the formula we're going to apply to part A. Probability of S intersection E, here it is, will be equal to the probability of S plus probability of E minus the union. We have all of these quantities, 30 over 51 plus 29 over 51 minus 44 over 51 results with 15 over 51. Because it's reducible, I do factor out a common factor of 3, and it leaves me with 5 over 17. Part B. Given that the student selected is a sophomore, what is the probability that she is also an English major? So we are looking for the following: probability of randomly selecting an English major, knowing that we are choosing from the pool of sophomores. We use the conditional probability formula, and to compute this probability of E given S, we need to find the intersection of E and S. Probability of that must be divided by probability of the conditional statement right here, probability of S. We just found in the previous part of this question the intersection of S and E, which is 5, 17, or even more conveniently 15 over 51. So that's the numerator, must be divided by probability of S, which is 30 over 51. So 15 over 51 divided by 30 over 51. Remember that division by a fraction turns into multiplication by its reciprocal. So 15 over 51 times 51 over 30. I reduce all common factors, 51 with 51, and a common factor of 15 from both 15 and 30, and it leaves me with 1/2. Please note that the solutions in both parts should be left in a fraction form according to the directions provided in this question.